All right, what's up, everyone? We are live. It is Thursday. We're doing some leak coding today. So if you are here joining me, if this is your first time, welcome. If this is not your first time, then welcome back. And what we're doing today is we are going to be doing one of the recent leak code contests. So I'm going to be doing the weekly contest number 294. And I will put that link in the chat for anyone who wants to follow along here. And so what I'm going to be doing is I'm going to be going through some recent problems. I'm going to be going through problems that I have not seen before. And I'm going to be showing you what is my thought process. How do I approach these problems? How do I specifically approach problems that I have not seen before so that you can understand, right? What is that thought process? How do I do this myself if I'm in an interview and I see a question that I've never seen before? So with that, let's go ahead and jump in. I'm going to share my screen. And all right, so we'll go ahead and start with our second problem here so that we have something that's a little more interesting than the super easy ones. Let's go ahead and take a look here. And if anyone has any questions, go ahead and put those in the chat as well. Don't expect me to immediately respond to them, but I will try and respond to anything that is relevant. So let's do this. All right, so we have n bags numbered from 0 to n minus 1. We're given two zero-indexed integer arrays, capacity, and rocks. The ith bag can hold a maximum of capacity I rocks and currently contains rocks I rocks. You're also given an integer additional rocks, which is the number of additional rocks you can place into any of the bags. Okay. Return the maximum number of bags that could have full capacity after placing the additional rocks in some bags. Okay. So I'm going to assume that sounds like each rock is basically one unit of, or each rock is like the same size, same weight, whatever our kind of units are here. And so if we look at this example, we have these capacities of 2, 3, 4, 5, and we have the rocks are 1, 2, 4, 4, right? So these two bags both need one additional rock, and this bag needs one additional rock. So in this case, we have two additional rocks, and this bag 4 is already full. So we can just add a rock to any two of the bags. Right? If we place a rock in the first bag and the second bag, that'll work. If we place a rock in, again, it really doesn't matter. So let's look at another example here. 10, 2, and 2, we have 2, 2, 0, and we have an additional rocks is 100. So we could put, what would that be? 8 rocks in this bag. We don't have to put any rocks in this bag. Sorry, 8 rocks in this bag. We don't have to put any rocks in this bag, and 2 rocks in this bag. And so we'd be able to fill up all the bags and have a bunch of rocks left over. All right. So with this, really, in terms of a brute force approach to this, we could basically try picking any combination of bags, right? And see, for that combination of bags, do I have enough additional rocks to fill up those bags, right? Essentially, and if I do, then I'm going to go through every possible combination and I'm going to pick the combination that gives me the most bags that are filled up all the way. So that would be a very easy brute force approach that we could take, as long as we can find all those combinations, but that's going to be very slow because there's going to be lots of combinations. And I think that this comes back to if you've been around the block here more than once, you've probably heard me mention that when I see this pattern of finding all those combinations, my mind immediately goes to, is there a greedy solution or is there a dynamic programming solution to this problem? And so in this case, I think that the logic seems pretty self-evident that if we sort it, basically if we went through the bags in order of bags that need the fewest rocks to bags that need the most rocks, that is going to give us the most number of bags, right? So if we could basically sort the bags by number of rocks, number of additional rocks they need to be full, then we could essentially just fill them in with all of our additional rocks until we run out of additional rocks. And that would be the maximum number of bags. And so I'm thinking like the easiest way to do this is going to be, obviously we have these two different arrays here. So it's non-trivial. It wouldn't be trivial to sort this directly, but if we created one additional array that basically included the number of basically how many additional rocks need to be added, then we could sort that array very easily and then just fill it in. So like here's basically what I'm thinking. And a solution like this is going to take n log n time. It's going to use O of n extra space. So we may still want to look at, is there a way that we could do this without sorting or without doing this? But here's basically what I'm thinking. And I'm going to assume that like this input is, I'm going to assume that the, yes, okay. Rocks is always less than or equal to the capacity. So I'm going to create some, I'm going to create some array, and then I'm basically going to say for int I equals 0, I is less than difference dot length I plus plus. I'm going to fill it in, right? So I'm going to say difference I equals capacity I minus rocks I. Right, so I'm going to do that, and then I'm going to sort this. So, right, because now I'm getting that in order, and now all I have to do is just iterate through the whole thing and see how many additional rocks it takes, right? So for I is less than length I plus plus, and I'm going to say, let's say count equals 0. I'm basically going to we could say, I'm just thinking what's the easiest order to do this in. So if additional rocks is less than 0, then we're going to see I think we need to return count minus 1. That's the one thing that's annoying me here. It's not, obviously this will work, but basically, so otherwise we're going to say additional rocks minus equals difference I and count plus plus, and then otherwise we'll return count at the end. But this also, we're not checking that last one. So what I'm really thinking is that an easier way to do this might be to say if minus difference I is less than 0, then break. Otherwise, and like we do this, and then we just return count at the end. I think that's a little simpler for our code. Because that way also, when we get to the end, we're going to be in the right spot. So if we do this, this I believe should get us the right result. Yes, okay. And the question is, efficiency-wise, is there anything that we can do to improve this? All right, here we go. All right, so we're pretty fast. Space-wise, we're not bad. I don't know, there's solutions down here. This is where I always question, it's like, okay, we could do this in less space if we used more time, right? Like we could do this without creating that extra array, but I always wonder when I look at this, for example, these these ones way down here space-wise, are these also efficient time-wise, or are those ones that fall into this kind of longer runtime up here? Right, so we never know. I mean, I guess we could look at like a specific example, but we could use additional space in our solution here by just doing a manual search, right? Like we could basically scan through the whole array. We could do a linear search for like what is the next capacity sort of thing. But I like this. I think this is a pretty clean solution here. If we weren't going to sort it, is there anything else that we could do? so we still, even if the only way that this works is for us to go through them in increasing order, right? And so the only way for us to go through them in increasing order would be for them to either be sorted, or you can hypothetically do some sort of like bucket sort if you know what the data is that we're working with, but I doubt there's anything there. I think we're basically going to have to sort it unless we want to do something slower, because unless it's in sorted order for this, we're not going to be able to do anything. The one thing that we could do that might save additional space is we might be able to do some sort of sort where we do like a custom comparator on basically where we would say that we're comparing the two values in the array based on the differences between the other arrays. I think we could do that, but then we need to sort both of them. So we would still then probably have to store one. We would have to make a copy of one of the arrays, which is going to defeat the whole purpose anyway. So I think this is probably going to be about as efficient as we're going to do. I'm happy with this. There's not anything that's like meaningfully faster. Cool. Well, that wasn't too bad. Let's look at the next problem. All right, so we're given a 2D integer array to represent stock prices, where we have the day and price. Okay, 2D array. A line chart is created from the array by plotting the points on XY plane with the x-axis representing the day and the y-axis representing the price. Okay, fine. Return the minimum number of lines needed to represent the line chart. Okay, interesting. So like in this case, we would have 1, 2, 3, 4, 5, 6. I think these look like they're 1, 7, 8, 9, 10, 11. This would be 3. And I think the key thing here is that if we have multiple points that are along the same line, we're counting it as a single line, right? So we had 1, 7, we had 2, 6, 3, 5, 4, 4. Then we go over, and then we go down again. Okay, so represents, I mean, I guess the logic makes sense. In this case, we're going just linearly up. All right, so, and it doesn't say that the day, I mean, in all these examples, oh, wait. No, these days are out of order. All right, so I do think that we need to, this is going to be really hard to do unless we can, actually, I guess I'm thinking, I have two ideas. So one is like, let's consider if these are, let's consider these being in order for a second, like if the days are in order. Right, so we would start with the first day, and the first day to the second day is going to form our first line no matter what. So if there's only one day, there's not going to be any line. And here, I'll actually draw this so that it's a little easier to understand. So my Apple Pencil has battery. It says it has 5%, so we're living on the edge here. I think I can also draw with my finger in theory. All right, so like if we have our graph, we're gonna add a point. We're gonna start with one point, right? And then we're gonna add some point, let's say over here. We connect them with one line. Now, there are two possibilities, right? Either let's say that the next point is like up here, right? And in this case, we're adding a second line. The other case, which I'll do in red instead, is that the point is like here. and we go like this, and so it actually becomes part of this same line. And so the question is, how do we know that? Like, how do we know? Because in this red case, we're just going to extend this current line. Whereas in this case, which I'm doing in black, we are creating a new line. And now, when I add a point over on this side, it's either going to be, again, an extension of this line, or it's going to be an extension, you know, in this case, of this second line, or it's going to be a new line again. And so basically the question is, how do I know for any new point whether it's adding a new line or not? And the answer is just, I really just need to compare the slope, right? I basically need to compare the slope between, if I take the slope between these 2 points, and then I take the slope between these 2 points, if those two slopes are the same, which is rise over run, right? We can just calculate that from the xy coordinates. If those two slopes are the same, then I'm just continuing the same line, and so I can just pick up from, you know, this point and continue forward, right? Whereas if the slope is different, so in this case, the slope is not going to be the same, right? Because here I have basically a slope of like, what is it, like 1/2, and this looks like kind of a slope of like 2, right? The slopes are not going to be the same, and so I know that that has to create another line. So if my points are in order, then, and I think this is going to be the easiest way to do it. Now, what if my points were not in order? And this is where I think we have kind of an interesting question here. Because I do think there's another approach to this. Because, okay, so to do this, I think it's fairly trivial. I mean, not trivial, but I think it's fairly straightforward how we're going to do this. We're just going to need to sort our array, and then we're going to go through the points and compute the slopes and compare them. Like, that part's fine, and, you know, count the number of lines. That part's fine. But what if we didn't want to sort it? Because, again, I think there is a way to do this without sorting. And here's what I'm thinking. Let's imagine, for starters, that we have our first 2 dots are like the ones on the extremities. What happens is we basically draw those first 2 dots, and then we draw a line between them. Now, we're going to add another point. And when we add another point, there's one of 2 things that can happen. The point is either going to fall on this line, which again, we can basically say by saying, like, of all the points that we have, what's the one immediately before, what's the one immediately after, and what is the slope between those 2 points, right? Now, that's one possibility. The other possibility is that it falls, let's say it falls here. Now, in this case, there's no longer a point there. In this case, what happens is we look at the slope here, and we look at the slope here, and we see, okay, those are not the same, so it's not on the same line. So basically, we end up splitting this one line into 2 lines. Now, if we added another point, let's say we added a point here, we would do the same thing again. We're going to split this line into 2 lines, and we basically have to find what's the point immediately before and the point immediately after. If we added a point here, then there's no point after, so it's just a question of, is it the same slope with this? So this is a slightly different case. It's like, is this slope the same as this slope? So we'll have to handle that case separately, but I think that this is probably going to be a more efficient solution. Because if we do this, so let me actually think, is this going to be a more efficient solution? What would be the complexity of doing this approach? Well, we're adding the points in, and then we're going to have to figure out when we add a new point, we have to figure out where it goes on the timeline, right? We basically have to figure out, when I added this point here, I needed to find this point and this point, right? And it's easy, once I find one, they're like, let's say I had a list of points. They're going to be consecutive in that list. So once I find one of the points, it's fine. But to find one point, I'm gonna need them to be in sorted order here. And so to find even one of the points, I'm going to need to do a binary search, right? Like, how else am I going to find that point? Because I don't know I'm looking for like what's the next smaller point from this. I'm not looking for whether this exists or not. If I was looking for whether this exists or not, I would just use a map and and it would be fine, or a set, and it would be easy. But because I don't, this is actually similar to a problem that we looked at last week. I think this is similar to that one of the problems that we looked at last week, where basically what we're doing is when we take this approach, if you really stop and think about it for a sec, what are we actually doing? We're actually sorting all the points, right? We're sorting the points because we are doing a binary search and looking for where the point it should go. And so when we think about it that way, we really should just sort it to begin with, because that's going to be so much easier. So considering these two possible solutions, I'm pretty confident that regardless of which one we do, it's going to require us to sort. It's going to require us to do the work of sorting. And so we may as well do the one that is more like kind of trivial to implement. And so if I remember correctly, I'm just trying to remember how do I actually do this, because I need to sort just on that first value, right? And so this is one of those ones where if you're not like me, you should actually learn how to do this. But if you are like me, you can Google it. Yeah, so to sort this, it's going to be something like arrays.sort stock prices, and then we want to sort on the new so basically I'm just going to implement and then return and I believe that this should work. So it's something like this. Let's just make sure it works. And I should make sure that we're using a sample test case that this is not sorted. Oh, this is fine. Gotta do this. So, okay. Yeah, it looks like that worked. Yep, okay. Cool, so now we can do the rest of it, which is just, we just have to calculate the slopes, right? Like we just calculate one slope relative to the next. And so to do this, shouldn't be very hard for us to do. We'll say, I mean, if, I guess let's handle this edge case first. So if right, because if we don't have any, if we only have a single point, then we're only going to have a single line. So we can, let's go ahead and say count equals 1 and equals so it's rise over run, right? So it's going to be what is it? Stock prices 1. So the second value is the rise. I mean, I guess it doesn't actually matter as long as we do it consistently, but 1 minus stock prices 0, 1. So that's going to be the rise divided by which is going to be this and this, and we need to do, let's make sure that we're actually doing proper division here, and we're actually getting a double. So we would have something like that, and maybe the easier would be to say, let's just do a, because we're gonna be doing this a bunch, right? So I think it would make way more sense for us to just break this out. It's also easier to understand, right? Because we don't have all these right, like this is a lot easier to read. So we'll do that. We might also need to worry about double comparisons because we may need to do like a comparison with some sort of degree of, like if we say two doubles are equal to each other and they're off by even like the tiniest little bit, we can run into issues. So we may want to do that, but I'm not going to worry about that now. Equal slope, it's gonna be stock prices 0, stock prices 1, right? So now we basically have our starting slope. And now what we wanna do is we wanna iterate through each value and compare. So, for int I, and we have the first 2 points. So I'm actually gonna start at I equals 2, and I'm gonna look backwards. I is less than stock prices dot length, and I plus plus. We'll say, we should call this previous slope, because I'm gonna have curve slope is going to be stock prices I minus 1 and stock prices I. And now we just say, if it's the same, we don't do anything. So if curve slope, and we only do something that's different. So if curve slope is not equal to previous slope, then count plus plus and prev slope equals curve slope. Right, basically if the slope is different, then we're adding another line. If the slope is the same, then we are just extending the current line. And with that, return count. Okay. This is where I think we're probably running into a, let me just grab this. Yeah. And so the question is it treating these as equal or not? Okay, so then that's not the issue here. So what's happening? We are just making sure that we're not just getting an obvious like overflow. So I equals, I guess this should be, because we're basically computing the first one. This should be, if I equals 2, 0, 1, 2, then we should be getting, this should be incrementing our count. Or no, it should be, it's telling me that this is, I guess I need to do the math on this, don't I? Can we just quickly graph this? I don't know that it'll accept input like this. I don't know what is valid syntax for plotting points, but I feel like it's usually pretty lenient. Okay, here. Yeah, like this looks like this should be a single line to me, but obviously with the scale, it's impossible to really tell. So I'm trying to figure out what the actual answer is, and maybe I really just should calculate this myself. So we get rise over run, which is 4,999,999,999 minus 1 divided by 4,999,999,999, and then this serious question for anyone in the chat here. Am I looking at this wrong? Is the answer not supposed to be 1 here? I'm pretty sure that the answer should be 1. All right, my iPhone calculator needs me to go into advanced mode here. So this minus, so it's a billion, or it's 999,998 million minus 4,999,999 is equal to 4,999. I'm pretty sure this is wrong. I'm pretty sure that the slope here, or that the number of lines should be 1. Unless I'm misunderstanding something. Let me go back. And how many cases did we actually pass? That's the other question. Okay, we passed all but 2 of them, or 3 of them. Or yeah, all but 2 of them. Unless I'm just missing something really obvious, even like doing the math myself, I'm getting that this should be 1. Let me just go back to reread the problem, and then maybe we can look at the discussion here real quick and see if anyone else, if I'm going crazy here. All right. I'm honestly still confused. I don't know. This is very okay. So I think the short answer is that it sounds like we're basically. Yeah, so I'm trying to understand what the issue is here. I mean, I get like it's definitely they're saying it's. I think the point is that it's a precision question, but um, like I get that, but I'm like, is that even right? I don't know. I'm sure it could be a precision question. At least I'm not the only one. um, I mean, this is also something that I like honestly would never worry about in like an interview proper. But I guess for the purposes of um, like I'm curious. I'm kind of curious. Um, I don't know. What did other people do? Like if I just yeah, okay, using a big decimal. That's super annoying. I mean, the other thing. Okay, here's the thing is that I just want to see if this works, and I honestly don't even want to write this code. So I'm kind of curious if I just like I'm just gonna hard code this just because I want to see how fast this runs. Other than that, so if let's just say stock prices. I'm guessing there's only one with this input, so equals this, and let's say right, because that solves that problem. Unless there's other ones that. Oh, okay. Oops. And I should actually, yeah, that's a. Fine. Did I do this wrong? Am I just. This should have been 0. And this should have been 1. Am I just. Even. I'm even doing a bad job at hacking the solution here. Okay. So it should be. This should be 1, 1. And this should be 2, 0, right? 1, 1, 2, 0. Oh, thought I had that right before. I see. There must be multiple. Oh, there are multiple versions of this basic exact same thing. It's kind of obnoxious. Fine, I'll handle this one too. I'm over this problem. All right, fine. Was that the dumbest thing I've ever done? Probably, but that's okay. Because this is what I was really curious about, because that particular input is short, so it's not like it would take long to run. This is not going to affect our overall runtime here, but I was just curious about how long this is actually going to take relative to the other solutions. So yeah, I mean, I think this is a pretty good approach in general. It's just, and you know, normally I probably wouldn't even worry about that precision for like a except for like a Leetcode question, because obviously they do some of this annoying stuff. But hopefully that logic made sense for how we approach that, because I know this problem's a little bit. This is one of these things where what we really need to do is when you just, how do I break this down into what is it that they're actually asking me to do? Right? At the end of the day, you can look at it and it can seem like a kind of intimidating problem, because there's all this stuff going on and there's all this visual stuff, which is like, what the heck? But it's not, it's a matter of just reducing it to like, what does it mean for there to be 2 lines versus 1 line? Right? That's really the fundamental question. What does it mean for the points to be part of the same line? How could I define that? How could I figure that out, right? This is like, you know, high school geometry. And I mean, it's not very tricky geometry. Hopefully, like, you know, you can figure out pretty quickly how to do this. But that's, when you're thinking about this problem, that's really what you need to keep in mind, and that's really how you need to approach it. All right, we have 15 more minutes. Let's at least take a look at this. I doubt we're gonna get anywhere close to an actual, excuse me, that we're gonna get that close to an actual solution, but we can take a look at it. All right, so as the ruler of a kingdom, we have an army of wizards at your command. You're given a 0-indexed array strength, where strength I denotes the strength of the ith wizard. For a contiguous group of wizards, the total strength is defined as the product of 2 values, the strength of the weakest wizard and the total of the individual strengths. Okay. Return the sum of the total strengths of all contiguous groups of wizards. And return it mod 10 to the 9 plus 7. Okay. So if we have these wizards, we have all the groups of length 1, we have all the groups of length 2, we have all the groups of length 3, and then we have the group of length 4. And I mean, computing these, I guess, is, you know, we have clear rules for how to do it. So that part's not too difficult per se. I guess there becomes this question of, so we can do some sort of like sliding window deal to compute all this, probably, right? Like I don't want to sum up everything multiple times, go through all that sort of thing. But what do we need to actually calculate for any one? We need the max, and we need the we need the min, and we need the sum, right? So we could do basically starting at each index and to the end, And I feel like that's always my go-to for things like this, and it's never ideal because what that leads to is I think the issue here is that we're gonna end up with some really long input, right? Strength dot length. Okay. So we're actually, I mean, it's not a crazy number. We're ending up with at most 10,000 wizards, which means that if we had like an n squared solution, I mean, is that going to be terrible? No. The question is, can we do this without, and I feel like there is I always forget what the right technique is for this. There's some sort of like, because what we have is we have a lot, we're computing a lot of like partial uh, things here that can be combined in different ways if we store the right information. I think since we only have 10 minutes, let's code up this simple version first, and then we can consider optimizations if we have time. So basically, I'm going to try for each starting point, and I'm going to have a, result equals 0. I'm going to have some, I will basically, for each iteration, now that'll be in here, right? So for each iteration, for each one, I'm basically going to have a sum equals 0, int min equals, well, I want it to be, like I could just set it to that first value, I guess. So strength start, it's probably easier. And then I'm gonna say for, basically I get my sum plus equals strength I, and then my result plus equals what is it? It's the sum times min, and then I need to do that result mod. Make sure I do the right number of zeros. I basically want 1,000,000,007, right? So it basically becomes this. I think that's it. Oh, and I need to update the min too. So right, so we do this, we get the right answer, we submit it, and most likely we're going to get a time limit exceeded. There you go. And how many test cases did that actually pass, out of curiosity? Okay, so that actually passed it. It's, reasonably quick here. There's like a handful that we didn't pass, but so I mean, this is like that took us like 2 seconds to come up with a solution. Now the question becomes, how do we come up with a better solution? And I think the big issue here is that we're computing all these, like, we're computing all these substrings multiple times. I mean, fundamentally, that's the issue. We could probably do some sort of like dynamic programming for this. Honestly, that might be the approach to take. Where so like how might we do this if we wanted to do dynamic programming? Essentially, we're or is that really the best way to do it? Because we could, what I'm thinking is that if we computed it for some subarray, then we could easily compute it for that subarray. If we compute the like all the, we basically would need to compute the result, we would need to compute the sum, and we would need to compute the minimum for each subarray. And if we did that, then but this is still going to take us like up a lot of space. Like, this is still, we're going to then end up basically implementing like an O of like an n squared size matrix to like store everything. It does feel like we probably need to do some sort of, something of that nature though, because otherwise we're not going to have, otherwise we're just going to be, we need to do something that's going to take us less than O of n time. O of n squared time. So what we need to do is we need to come up with a way that we can avoid basically recomputing for the different subarrays. So like once we've computed for one subarray, how do we combine that with the next subarray and the next subarray? But even if we did that, like let's say, for example, that we compute all the subarrays of length of the results for all the subarrays of length 1, and then we like merged them into all the subarrays of length 2, and etc., and like kind of repeated that process, it would still take us O of n squared time. I don't know. I know there's an algorithm for this, and I'm just blanking at the moment on what it is. I do have to wrap up here, but I do appreciate everyone joining me today. Hopefully, this was helpful in terms of getting a better sense of that thought process, especially for some of those ones that are a little bit trickier in terms of how to think through the problem, right? And in terms of like what are they asking us in the first place. So hopefully that was helpful for everyone. Appreciate everyone joining, and I'll see everyone here next week.